Okay, we have a short hour today, not a lot of time to cover, but we'll get through what we can. We left off yesterday looking at these type of functions. Let's just get our brain back in order. We said that the graph of 1 over x to the fourth looks exactly like that. And if it does look like that, then we identified that in order to evaluate the limit, we have to evaluate from both the left-hand side as well as the right-hand side. So if I'm approaching 0 from this side, what does the function value approach? Positive infinity. And if I approach from this side, what does the function value approach? Positive infinity. And what you learned yesterday, the key learning is that if the right-hand side limit is equal to the left-hand side limit, then you could say that the limit exists. So in this case, we looked at 2x plus 3 over x minus 1, and you can see that we ended up with this type of graph. And as we approached positive 1 from this direction, you can see that the graph approached what value? Negative infinity. And as we approached from this way, the graph approaches. And because there are two separate distinct values for the limit, it does not exist. So we said in this case, we have a limit of infinity. In this case, the limit does not exist. So what does that mean? In plain terms, for the limit as x approaches a value of a function to equal infinity, basically what that means is as x approaches a number, the output gets very large. Small would be closer to 0, large would be closer to infinity. So, if we do have this type of situation, as you can see right here, there is something special that we have that goes right between those two graphs. Do you know what that green line is called? A vertical asymptote. And in this situation, we have one right here as well. Okay? And so, to save time, instead of filling this all out, it says if x equals a is an equation for a vertical asymptote, then one of the following statements must be true. There's really 6 of them, but really the idea is this. If the limit of the graph approaches infinity from either the left-hand side or the right-hand side, then there's going to be a vertical asymptote. Can you understand that? So that's really what happens. So example 5 says identify the equations for vertical asymptotes in example 4. Vertical lines have equations that look like what? X equals. So we have an x equals and we have an x equals. And then I simply identify the value where the vertical asymptote exists. What will it be in problem A? 0. And the reason is you can see that 0 is where the denominator is undefined, or where the function is undefined, 0 in the denominator. So x equals 0 will be my vertical asymptote. How about in the second problem? Why do you see that, Tyler? What about that problem tells you it's 1? Okay. And if you look here, you can see that in the denominator, 1 is the spot where it's undefined. And so we will have 1. Good job. So x equals 1. So you should be able to identify vertical asymptotes as well. That wraps up that. Let's get to some algebra pieces. Yeah, we'll get through. Okay, so section 2.3 really says this. It starts out with then identifying certain laws of limits, and these are helpful for us to identify. If we begin here, it says the limit as x approaches a of f of x plus g of x. So if you had two things added together, let's say that you had x squared minus 3x, you could simply take the limit of those two pieces separately. In other words, the limit as x approaches a of f of x, and then you could add on to that the limit as x approaches a of g of x. And time to pause the recording because Rachel Kennis decided to disrupt my class. We continue. So I can separate these into two separate limits. What do you think happens with subtraction? I subtract. What do you think happens when I multiply? I then multiply them. What do you think happens when I divide? I divide. What do you think happens when I multiply by a constant? I can move that constant out front just to show you what that looks like. We're not going to do all of these because it's pretty common sense, and this will help save us some time and your ability to focus. So c times the limit as x approaches a of f of x. So you could just move that constant out front. And these are just properties that really help us work with limits. So dividing, you kind of get the idea. Taking to a power, you get the idea. This is something we should look at, though. I want to write an example right here. The limit as, say, x approaches 1 of 4. Think of the function f of x equals 4. What kind of graph is that? F of x equals 4. A straight line, horizontal line. What is the output of that all the time? 4. So what's the limit going to be as x approaches 1? 4. What's going to be the limit as x approaches negative 20? It will always be 4. So the limit as x approaches a of a constant will always be equal to that constant. Make sense? So how about this graph? Let's say we have the limit as x approaches 5 of x. What does that graph look like? What does the graph of f of x equals x look like? It's a line that has a slope of 1, and it passes right through the origin. So let's think about it. As x approaches 5, what do you think the output approaches? 5. As x approaches 6, what do you think the output approaches? 6. And so whatever the a value is going to be what the output approaches. Now, you really don't need to remember these. They're going to really be common sense for you. As a matter of fact, we can use this method, which we call direct substitution, for a polynomial or rational function. If you want to evaluate the limit as x approaches a of f of x, you can simply plug in the value to the function. That's where we started out in this class. We said, for a lot of nice functions, you could just plug them in. The question is, what if they have vertical asymptotes? What if other things happen? Then it's a little bit more difficult. So let's just look at a couple examples here. And these will be examples on your test, but they should be pretty straightforward. It says, given that the limit as x approaches a of f of x is 6, and if g of x is negative 2, and that h of x is 0, I want to identify these, and if it doesn't exist, I want to explain why. Now, the first thing is, are these all approaching the same value? Yes, they are all approaching what value? A. And so because they are, we can use our properties from above. If I wanted to find the limit as x approaches a of f of x plus g of x, what I do is I find the limit as x approaches a of f of x, and then I add on the limit as x approaches a of g of x. Do you see this up above? What is the limit as x approaches a of f of x? 6. What is the limit as x approaches a of g of x? Negative 2. So if we wanted to add them together, we then get 4. And we do that for really each step. You like that, Kyle? Yeah, Kyle likes it. Okay, good. What will I do with b? I could simply divide them. What's the limit as x approaches a of f of x? 6. And how about h of x? Ah, yeah, there you go. Limit does not exist. Why? Because 0 is in the denominator. Very good. In this situation, we could simply, work with the numbers that you see here. We could separate this into pieces. Really, we just need to identify what the limit as x approaches a of g of x is. What is the limit as x approaches a of g of x? -2. So I have -3 times -2 plus 5. Positive 6 plus the 5, you get 11. And the last one, I have the square root of h of x times g of x. 0 times -2 plus 6, which is going to give you 6. Does that make sense? I want you guys to know this will be a reoccurring theme throughout all of calculus, that instead of giving you actual functions to work with, they will give you values, whether that be derivatives, whether it be integrals, and you have to apply the properties. I expect that these are gimme points on the test. Okay? I will probably switch the questions to some degree. I might, use 5 and stuff, but very, very, very similar. Very similar, okay? You guys know that I state everything that you're going to see on the test. Okay, so I really like this. I'll tell you, if I was your teacher, I would maybe think about putting this on the test. Instead of giving you the actual values, I tell you that you're looking at the graphs, evaluate the limit. If the limit does not exist, state why. So this is the limit as x approaches 1 of f of x times g of x. This is f of x. This is g of x. So I first need the limit as x approaches 1 of f of x. What's the limit as x approaches 1? It is 3. How do you get 3? As you look here, you can see that it is approaching 3. So very good. Times so as I approach 1, the output value is approaching a height value of 3. Yes? Okay. Now I go to g of x, and as I approach 1, the output approaches -1. I multiply those together, and I get -3. Let's try letter B. How about x approaches 0 of f of x? What will I have? 2.5. So I have 2 times 2.5 minus 3 times -2. That'll give me 5 plus 6 is 11. Any questions how I'm doing that? What I really like about this problem is you have to use the properties from before, and you have to use the idea that we used yesterday in order to evaluate limits graphically. So this is a really good summary from yesterday. Let's look at C. Limit as x approaches 2 of g of x. X approaches 2 of g of x. What do you see? Nope. It's not 0. Let's look, boys and girls. As you approach from the left-hand side, you approach 0. As you approach from the right-hand side, it does this barcode thing. So that does not exist. If any part of it does not exist, the whole thing does not exist. D and E. Okay, let's try one that's a little bit trickier. Letter D. I'm going to forget about this 2x squared, and I'm just going to look at the f of x first. What is the limit as x approaches 5 of f of x? Positive 4. So I'm going to break this into two pieces, okay? Just so you understand. The limit as x approaches 5 of 2x squared times the limit as x approaches 5 of f of x. Now, you guys told me that this right here is equal to what? 4. Great. Times, do you see the graph of 2x squared up there? No. Do we need a graph? Isn't this just a polynomial? And if you want to find the limit of a polynomial, what do you do with this number? Plug it in. So you have 2 squared is, or 5 squared is 25 times 2 is 50. So don't let that confuse you. It's just asking you, suppose you had the function 2x squared. Well, that limit would be 50, and we multiply by 4, we get 200. Any questions? Okay, please write this down above here. Graphical. Well, in this situation, we should really explain that. That's a good point. And we would write, the reason why we would write that is we would say the limit as x approaches 2 from the positive of g of x does not exist. So therefore, the whole thing doesn't exist. If you wanted to give a further description, you could say that, this represents the barcode piece. But really, most of the time, if you're going to write the limit does not exist, you would write because the right-hand limit is not the same as the left-hand limit. Would that be true in this case as well? Could I say the right-hand limit is not the same as the left? I sure could. It would be harder to say if my graph looked like, that. If it looked like that, it would be harder to convince somebody that the right hand is not the same as the left hand. But in this situation, it's pretty clear. Does that answer your question? Kelly, you started out with a question yesterday about asking limits as well, and I said, let's wait and see how the next section goes. Is your question answered from yesterday too? Okay, so let's move to this. Write down graphical. We have evaluated limits graphically. We have also evaluated limits by using a table. Sometimes, if somebody gives me, let's say somebody tells me, Mr. Gens, what is the limit as x approaches 0 of sine of x over x? I know it's 1. Why? Because there's also a process called analysis. That's probably the hardest, where you have to have really true knowledge of the behavior of that function. So these are 3 ways that we have been able to identify limits of a function. The last one that we're going to use would be your favorite, would be algebra. Okay? We'll start basic. Limit as x approaches 1 of this function. Can I plug 1 in? It is a polynomial, so I can do that. 1 to the 4th minus 3 times 1 squared plus 1. I have 1 minus 3 plus 1, and I get -1. That's it. Here I plug in 0. Can I plug in 0 and evaluate this? I sure can. Very good guess, Ben Jones. Not entirely correct. -3. Remember, cubed roots, we can have negatives under the square root sign. However, for square roots, you cannot have negatives under the square root sign. Any even root, that would be correct. Okay, let's begin the algebra. This function is undefined at exactly 1 value. What value is that? 3. In fact, if you graph this, we started with this problem a long time ago, and Ben Jones made a very profound statement about the nature of that function. He said, it's actually a line, Mr. Gens, and it looks like this, and then we realized that there was a hole in the middle of it. And that's the same way with this function. I cannot simply plug in 3 because it would be undefined. You would get 0 in the numerator. You would get 0 in the denominator. We can't have that. So we just use some basic algebra. What can we do to the top? I'm going to say something you're really going to be upset at me. You have to continue to write the limit here until you actually plug in 3. Okay? So, what cancels off? So this function actually looks like x plus 3. So now, can I plug the 3 in? So that's equal to 3 plus 3, which is 6. So I didn't have to write limit anymore because I actually plugged in the 3. But for notation, you do have to write it. And you may say, Mr. Gentz, you're being too technical. I remember sitting in my calculus class. I remember getting points taken off for not showing the notation correctly. So just trying to save you some heartache from the next year. Okay, letter D. What should I do now? Why? Is it undefined at 0? Okay, make sure that before you start all of your progress of trying to factor and use algebra, that you're sure that it's actually undefined. So this is undefined at 0. If you plug in 0, you get 0 in the numerator and the denominator. You guys are right. We should write this as the limit as x approaches 0 of, now we factor out the x in the top. What are you left with in the top? X minus 5. Divided by, in the bottom, x times 1 minus 4x. Okay. The x's cancel. So I have the limit. If I wanted to write another step, I could. So the limit is x approaches 0 of x minus 5 over 1 minus 4x. Can I now plug in 0? I can. So I get 0 minus 5, which is negative 5, divided by 1. Any questions on that? Here where x approaches 3. The problem is we're undefined. Yeah, and you guys, just one more second because this was a good question. You guys remember as we did this one, this line actually looks like x plus 3. This actual graph looks identical to this. We said that there's just a hole there. All we did is we just really removed the hole. That's all we did. And then we were able to evaluate it. Yeah, essentially. And we'll get back to that, points of discontinuity and how we work with that. Okay. All right, these are much more interesting and a little bit more challenging for you. Please change this letter here. Let's write this, the limit, as x approaches 4 of, let's go 4 minus x over 2 minus the square root of x. And let's change h to the square root of h plus 9 minus 3 over h. Let me cross it off. Thank you, Tisha. You got my back. That's how we roll. Whoa. Hey, I got you to laugh, all right? Yesterday you were a little pouty face. Now you're smiling. I got my job done. Okay, let's try this. What do you want to do here? First of all, I want you guys to know that there are situations where you can't do it algebraically. You can't just get stuff to cancel out. You can't all of a sudden make magic out of it. There's times where that won't work. Now, we're going to try to limit those times, but there are times where you would have to go to a table and go from there. But we can show algebraically here exactly what this limit is. What do you want to do? What do you want to do? You want super smart people. What do you want to do? This one. Can't plug in 0. 0 doesn't work. Kelly Sanderson, be the voice of reason. That's a good thought. Ultimately, it will lead us to circles. Let's just. It is factored. Let's square it out. Let's FOIL it out, people. Limit as h approaches 0 of what is h minus 2, quantity squared. Very good. So Kyle sees where this is going. A lot of this is going to be problem recognition. You can tell that as we square it out. I have my 4, my negative 4. Those do cancel. So now we have the limit as h approaches 0 of, Kyle said take out an h, so we'll do h times h minus 4 over h. What happens to the h's? They cancel. Yes. Can we now plug in 0? That is the limit of this function as h approaches 0. If we looked at a graph of this, it would look like that. Okay. There is a point of discontinuity at 0. But we removed it. Okay. So I suppose the point 0, negative 4. Yeah. Okay. All right. F is a little bit different. Now we have to cube that out. Limit is h approaches 0. If we take h minus 1 or h plus 1 and we cube it, save us time, I will do that. We get h to the 3rd plus 3h squared plus 3h plus 1 minus 1 all over h. Okay, before we broke to do that, my good friend Jalen had a thought about this. She said the 1s cancel. Would you agree? Okay, so we cancel the 1s. So I now have the limit as h approaches 0 of, and I'm going to factor out an h. So I have h squared plus 3h plus 3 all over h. What cancels? I have an h that's going to cancel. And if I do that, can I now plug in 0? I will get 0 plus 3 is 3. Any questions on that? Okay, you guys, we have time. My goal is to give you all day tomorrow to work at class, and then all day Thursday for a study guide. So let's just see if we can get through a couple more of these. Okay. I changed that problem to the limit. question is, somebody asked a very good question. They said, Mr. Gibbs, why do you change it? I did that problem last year, and as I was coming up with problems, there's some that can't be solved by algebra. They require analysis. That's one of those, and I decided we're not going to pursue that route. So as I make changes year to year, I made that change in my notes last year to say, you know what, we should write a new problem, and so that's what we're doing. I didn't make it the actual change within the software, so I guess the option is, do I give you notes, or do I just have you copy them all down by hand? So that's what I thought. So this is a little bit more complex. This requires some forethought and knowledge of the function. First of all, can I plug in 4? No, I cannot. Any thoughts? Okay, there are 2 methods for doing it. Andrew points out one that you might be less likely to see. Let's look at that route. I'm going to argue that the top is the difference of 2 squares. Limit as x approaches 4 of what times what is 4? So I have 2 times 2, and what times what is x? Square root of x. So I can have plus the square root of x, and I can have minus the square root of x. I think we should applaud Andrew for his foresight. That was very nice. Okay. So, hold on. Jalen has a question. Jalen, and then Tyler. Problem recognition, you should see it. I'm going to show you another method that you could try. Tyler. You can write the other method down if you prefer. As you can see, the 2 minus square roots of x will cancel, and then you could go from there. Here's the other method that you could do. A lot of people look at this, and they want to free up an x. And so one thing we could do is we can multiply by something very special. It starts with a C. Conjugate. If you multiply the top and bottom by the conjugate, that's going to get rid of this square root piece, and that's going to help us out. Watch what happens, boys and girls. 2 minus the square root of x times 2 plus the square root of x. 2 times 2 is, so I have the limit as x approaches 4 of, in the denominator, I will have 4. The reason why we multiply by the conjugate is because the middles go away, right? You will have a negative 2 square roots of x and a positive 2 square roots of x. So those will cancel, and we'll just end up with the end, which is a minus x. Well, that doesn't really work anyway, does it? We still end up with 4 in the denominator. Looks like multiplying by a conjugate is probably not a good result either. Got to factor. Yep. The next one we do multiply by the conjugate. Yeah, but if we plug in a 4, now we're in trouble. Still doesn't work. Nope. Nope, it won't. It won't. Okay, we have time for one more. Oh, it does? Oh. Okay, I'm sorry. I didn't see the problem all the way out. You guys say that the top does end up giving you something that will cancel? Sure, yeah. We don't actually have to FOIL that out. You're right. We could cancel it out and do that. Yep. Yep. Good. Good. Good foresight. Okay, now the next one. This is a little bit more complex, and we'll end with this. H plus 9 minus 3 all over H. Okay, we can't plug in 0, can we? The trick here is we are going to multiply by the conjugate. and the conjugate is the square root of h plus 9 plus 3. And so the bottom also has to be the square root of h plus 9 plus 3. Now, really take my advice on this before you try to distribute everything and work too hard, okay? Let's just look at the top. We have the limit as h approaches 0 of, what is going to be the square root of h plus 9 times the square root of h plus 9? H plus 9. Now, because this is the conjugate, what's going to happen in the middle pieces? It'll go away. You'll have 3 times square root of h plus 9 and negative 3 times square root of h plus 9. Those will cancel. And so it'll be left with just the n, which is negative 3 plus 3, which is, I'm sorry, negative 3 times 3, which is minus 9. Very good. Divided by, now don't distribute. We just write this. H times parentheses, square root of h plus 9 plus 3. Okay. What's going to happen to the 9s? The 9s do, in fact, cancel. The h's also cancel, which gives you what in the numerator? 1. So we're left with the limit as h approaches 0 of 1 over the square root of h plus 9 plus 3. Can I now plug in 0? Yes, and I get 1 over 6. We'll have to leave the rest till tomorrow. I'm going to pause this. I'll put your assignment on the board. You have all day tomorrow to work after we just get through those 2 examples. And then you have all day Thursday to work on your study guide. You'll be given your study guide tomorrow at the beginning of class. And you should be good to go. I'm going to put your assignment on the board right now. Just let me pause this.